We're now going to look at drawing ray diagrams for concave lenses. We've done some for convex lenses, and we saw there were three possibilities. You could get a real image or a virtual image. This diagram is going to look a little more complicated to draw, but we always get the same thing. So it's a little bit simpler in the long run. We have three rays we use: a parallel ray, a center ray, and a focal ray. And if you look at the video that shows those three rays, you'll see that the wording and the description is exactly the same for drawing those rays on this. Part of the reason is, on this type of diagram for a concave lens, the primary focus is not on this side, opposite to the object. The primary focus is on the same side as the object, and that's how the rules end up juggling to make them work properly. So let's take a look at it. We had a parallel ray. A parallel ray hits the lens. Keep in mind, this line represents the lens. This actual picture of a lens is there just so you know what kind of lens it is. So it hits the lens, and in the rules it said for a convex lens that a parallel ray goes through the primary focus. But the primary focus is on this side. So what I'm going to do is I'm going to bend that ray so that it sort of goes through the primary focus. It's going to go like this, up that way, which is, if I trace it backwards, when the light goes through the lens, it bends in such a way that it goes through the primary focus. So I have to bend it and trace it back through the primary focus. The center ray, well, that's easy. It just goes through the center and keeps going, just like the other diagram. And as I mentioned before, you only need two rays to locate the image. These two rays don't actually cross, but if you trace this one back, it meets right there. So my image is right here. Now I'm going to confirm it with the third ray, but I don't really need that. I know it's where it is, how big it is. I know it's virtual because I did this thing where I traced it back. The three rays didn't meet, but we're going to do that ray anyways. The third ray was for a convex diagram. It went through the secondary focus and then parallel. But the secondary focus is on this side now. So the ray, I'm going to aim it at the secondary focus. And as we said, a focal ray, when it goes through the lens, it becomes parallel. So I'm going to aim it at the secondary focus. When it hits the lens, it's going to go parallel. That ray was aimed at the secondary focus and went parallel. So I traced that back, and no surprise, it meets at the same place. So to describe the image, I have to describe its orientation. It's upright. The image type is virtual because these rays didn't actually meet. The size is smaller. The location is between the primary focus and the lens, so it's closer to the lens than the object. And the magnification, height of image, so I measure that, over height of object, it's going to be smaller, so it's going to be less than 1. So let's try with this. One possibility is the object's beyond the focal length or primary focus, and one possibility is it's closer. These are the only two diagrams you'll end up ever drawing. This might be somewhere slightly different, but it's beyond that, or it's between the lens and that. So let's look at what we did. A parallel ray bends through the primary focus. So that's the one that I bent, so I could trace back through the primary focus. A center ray goes directly through the center, like that. So these two rays meet right here. This is my image. Okay, I had to fix something on this. So the third ray is the focal ray. The focal ray is aimed at the secondary focus, and when it goes, at the secondary focus, and when it goes through the lens, it refracts parallel. So let me draw the third one. I'm aiming it at the secondary focus. When it hits the lens, it's going to go parallel. There it is. I trace it back, and again, no surprise, it ends up meeting at this point where I located my image. So if you look at the description of this one, it's upright, smaller, and virtual because the three rays didn't meet. If you look at this one, upright, smaller, virtual. What that means is for this type of lens, there's really only one answer. If you want to know what does the image look like in a concave lens, it's always upright, smaller, and virtual, no matter where you put it. So if I look at across the classroom and I look through this lens, which is concave, and I look at that point, everything's smaller and upright. If I look at my finger here, it looks like my finger is smaller and upright. So that's the only type you get with this. So that makes it a little bit simpler than convex.